Hi everyone. I am developing Line Android clients. My name is Ishikawa. In this session, I will talk about how the Line Android client team has been fighting against technical debt, especially over the past 2 years. Here is the agenda. First, I will talk about why we had to fight against technical debt. Second, what we have been doing to pay back technical debt. So first, I will explain why we had to pay back technical debt. To start from the conclusion, the reason is that the Line product is still in the course of development. Product life cycles can be divided into 3 stages: the product launch, growth, and the maintenance phase. At product launch, we must, of course, focus on development speed. During the maintenance phase, we focus on stability. But because the Line product is still growing, we must perform feature additions, deletions, updates. And therefore, we must focus on development. In this development phase, we must add more features, updates, and focus on speed and stability. And this requires continuous refactoring. I would like to give 2 examples to explain how we have been refactoring. First is the click listener for image messages. An image message, as the name goes, is to send and receive images in the form of a message in a chat. When this is clicked, if you can look at the right of the slide, the image will be expanded. The call stack that processes this click. I'm sure some of you cringed when you heard click listener, but there are 5 call stacks levels. First, when image view is clicked, this is handled by the listener, and that calls a different listener, converts to a different listener, and another listener is used. And at the end, finally, the image expansion activity is executed. In such a method, if there is a bug somewhere, it is very difficult to find it. Therefore, we refactored in the following way. We decided to stop using a listener and started calling directly so that the presentation logic receives the data directly, and created a utility method for the activity. In this way, we were able to reduce the stack this much, from 5 levels to 2 levels. My second example is the message input view. This is the green box that you see here at the bottom of a chat screen. This looks very simple at first glance, but it includes many features. You can use it to send text messages, but also send stickers, voice message, VoIP, and so on. These features were added afterwards. In other words, the feature was expanded. So the dependency was as you see here. This is a simple diagram showing the dependencies. There are lots of loops. So if there's an edit to any part of this, there could be an infinite loop. So how did we refactor this? In such a situation, we applied the mediator pattern. As a result, that dependency relation changed to this, which is much cleaner. With this system, even if one part is changed, the mediator handles that so that it does not or hardly affects other components. So I gave two refactoring examples, but here is what we learned from these cases. When we looked at just the result, refactoring is easy, and it looks much simpler done than said. But refactoring is actually very difficult to do because the refactoring process in itself is very difficult. We need to think about what kind of method to apply, what would be the final form, what is the current status. These are some things that need to be considered. This requires experience, knowledge, and insight. Here is another reason why refactoring is difficult. We must continuously develop the app and do refactoring at the same time. So there was a pressure on the engineers to develop features. This is another reason why refactoring is very difficult. Here are some features that we have developed over the past 2 years. These are just the most important features we've developed over the past 2 years. If we include more minor ones, the list would be much longer. So we must develop and update these features, and while handling this pressure, we also had to pay back technical debt. So, how can we foster or encourage the payback of technical debt? We did the following. First, we built an environment that allows technical debt to be paid back more easily. So what did we do? The environment that we improved can be divided into three. First is the coding environment. Second is CI, in other words, continuous integration. Third is the team environment itself. First, I will talk about the code environment. In order to improve the codes, we introduced new libraries and languages as new weapons. For instance, 2 years ago, we introduced Reactive X, and last year, we introduced Data Binder. This year, we introduced Kotlin that is officially supported with Android. There are many benefits by introducing Kotlin. One is that we can reduce a lot of Java boilerplate codes. But just by introducing Kotlin without carefully analyzing it can have many drawbacks as well, such as the following example. The apply method is one of the standard functions of Kotlin. This isn't quite accurate, but the function is taken as a parameter, and it is executed with the receiver scope. In this example, the scale type and image matrix in the brackets are parameters of image view. At the same time as you inflate them, you can initialize the property so that you can create an object, initialize, replace, return, and so on. But this apply can also be nested. In this example, within the image view, apply is used in the matrix reinitialization. And another nest was created, and if a call is made, the method in some scope method cannot be distinguished. It might be from image view, it might be for a matrix, or it may be for a point. It is unclear here. Also, it might be from a class outside of this or a global function. This is an extreme example, but in this way, if Kotlin is used hastily, the technical debt will increase. So, it is not enough just to introduce new tools or weapons, so to say. So we thought, what should we do then? We decided we must set limits as necessary. To explain in more detail, there are two limits. First, create coding terms, including best practices, and create library wrappers to limit its use. Let's take a look at each of these. First is the coding terms or conventions. To give an example, in our coding convention, it says we should avoid long lambdas. Here, let's give you a good and bad example and compare them. First, here is an example of a code that doesn't follow the convention. At first glance, you can't really tell what this is, can you? Let's look at it from the top. The first map function shows the group ID and converts that to group object. Then, it only takes the unblocked friend object and does something with it with for each. But it takes a long time to read it, and you can't really tell what this code tried to do or accomplish. One way to make this follow the convention is to use the lambda. As a result, this is what happens. The code is much cleaner and shorter. Even if you read line by line, you can see that the member ID is converted to data object. In the second line, only those who can communicate are filtered, and third is for each. In this way, by creating appropriate coding conventions, it helps developers to write better codes. Next, let's look at the library wrappers that limits its use. I will focus on Reactive X for my example. Reactive X is a great library that can be used for streaming or asynchronous processing, messaging, and handle them in a consistent way. But because the concept is so great, some people might think the whole world is made with reactive. If you think in this way, the following code could be something just to write 0 and 1. Maybe some of you have seen codes like this in here. You simply take a range of 0, 2, create a map, and create a list. This is obviously overkilling it. Although you are using Reactive X, this is obviously not reactive code. So why did this happen? Reactive X is a wonderful library, as I say, but it can be used for so many things. As a result, it is easy to abuse it. Therefore, we decided to create library wrappers so that libraries are divided up and set limits so that it cannot be abused. Here is an example. As a Reactive X wrapper, we created something that only extracts event bus. This is the example that shows what I mean. The way to use this event wrapper is for event paths similar to Guava and Green Robot and other famous event bus. By dividing up the libraries for various uses, it is possible to improve the use. So that was a summary of how we improve the coding environment. We introduce new languages and libraries with limitations as seen necessary. Next, I will explain about CI. CI and technical debt seem to have no relation at first glance, but CI supports paying back technical debt in the following ways. First, by making code change easy. Second is to enforce rules to prevent more technical debt. Third, to allow visualization of codes so that team members can be aware of technical debt. So what kind of tools did we use to achieve this? Here is the list. Of these, the green ones are the tools that Line created. Red are the ones that are publicly available. I would like to give you about 4 examples. First, there are 2 tools that we use to make code change more easily. One is to allow pull requests more easy. We are using GitHub at Line, but by reviewing codes on GitHub, we believe that engineers can write better codes. So, if we support engineers to allow them to better review codes, they can write better codes. In this way, we have developed a bot that allows engineers to write comments to peer reviews. This is an extraction from the bot. Every time there is a git push, a bot generates this. Let's look at what's included in this extraction. First, the very top, there's a link to the issue tracker that handled the peer review. And this shows why a pull request was needed and background to the specification. Second, there's a command to check out the code itself. Using this allows engineers to better or review in more detail. Third is download and install SDK. This command allows engineers to see how the code runs on their test device. Lastly, there is a pull request reviewer suggestion, so that if you look at code that you're not familiar with, you can see who would be suitable to review it. Here is how we implemented these. It was very easy. It only took 3 steps. First, we prepared a CI server. We ran the PR builder job. On top of that, we ran the script, but this script only calls the GitHub comment API. That's it. In 3 steps, engineers could write codes with ease. If you'd like, please try it yourself. Next is another tool that helps code support, is the branch merger. Before talking about the merger, let me talk about how we branch manage at Line. At Line, we have a release branch and trunk branch, just 2. On the release branch, if there is a bug found, we fix it on the release branch, and once the APK is released, we merge it back to the trunk branch. This is a common branch management method, I think. But if we add a refactoring command here, what happens? The accumulated refactoring may cause a major conflict. Which commitments are conflicting is hard to see. Even if we could fix it, the pull request to resolve the conflict needs to be reviewed by someone, and that is not easy to tell who is suitable. If there is a release branch, we cannot refactor with this method. This is why we built an auto merger for release to trunk. As you can see here, auto merger regularly merges release to trunk so that small conflicts occur at an early stage. By doing this, each conflict can be resolved more easily.
So the question is, how did we implement this? So we fetch the trunk and we merge it to the release. And if there's no conflict, if test is going well, then we git push and push it to trunk. If there's a conflict, line notify will be used so that team can know through the chat. And this is the contents of that. So you know what type of file is showing a conflict with a sad-looking sticker. By doing so, you know who can fix the conflict in a very easy-to-see manner. And also, on CI job, you can run this on regular basis so that you don't have to worry too much about release branch and focus on refactoring. Number 3. By imposing rules, we can talk about issue tracker police. The code and change we've made, we make sure we go through the testing by QA. And that QA test task will be managed by the ticket on an issue tracker. So if the code is changed, then the person who changed can or is responsible for writing a possible impact on the ticket. Simply put, all the pull requests should have a corresponding issue ticket. So we created a bot to monitor that. And this is the output from issue tracker police. If a specific branch has no corresponding ticket, then Sally gets upset and fails the test, so that pull request cannot be merged. So how did we create this? Just like comment bot. On pull request builder, we run script, and on that script, on the pull request title, we check whether the ticket number is available or not. That's all you need to do, and you can be ensured with a good refactoring. To close off, let me talk about Gradle version plugin from a perspective of visualizing the code status. This is using public available plugin on open source. The prerequisite is that old library itself becomes a technical debt. When there's an emergency update, it's really hard for us to apply that. And also there is an interdependency between libraries, but it's really difficult to resolve that. Therefore, it's hard for us to create or use the latest tools. Therefore, in order for us to visualize the current library status, we decided to use this open source tool called Gradle Versions plugin. This is the output. And the output can be viewable from the internal page of a project. So whoever notice can update the library on his or her discretion. So we created the tools, and I gave you an example of the tools that can contribute for a CI improvement. We can simplify the code change, we can impose rules, and we can visualize the state. By doing so, CI can help support to repay the debt. Let me talk about the team improvement. Due to the time constraints, the topic will be quite short. But personally speaking, I think this is the most important work that requires a tedious efforts. As a team, how can we fight against technical debts? There is this one thing we need to avoid. That is that somebody keep creating a technical debt and some other people need to pay for that debt. To prevent this from happening, we decided to do the following. 1 is to change the culture. 2 is to share technique and knowledge. Technology and knowledge. Let me talk about changing the culture. I'll give you a good example. We decided to thoroughly apply Boy Scout rule. Boy Scout rule is the concept created by the father of Boy Scout, Robert Payden Powell. When you go to a campsite, you have to make sure that the campsite needs to be cleaner than you came before. Of course, the same can be said for engineers as well as the code itself. When we make changes to the code, we should also clean up the surroundings by doing refactoring. By doing so, technical debt payment and functional implementation can coexist. Next is sharing of knowledge and technology. It may sound general, but at Line, we have a weekly tech talk. And also, we centralize documents so anybody can see the information. And we also set up time for self-learning so that we can improve our skill sets as a team. So let me summarize what we do as a team. We are trying to focus on changing our culture and also spending time and knowledge to share the knowledge or intelligence. So I would like to conclude this session by giving you the conclusion. First of all, we are developing functions, and also at the same time, we need to do the refactoring. In order to do so, we have been improving the code, CI, and the team environment. Code requires something new, but also sometimes requires some limitations. And with CI, you need some assistance to change the code. You need to impose rules and also to visualize the code status. And team worked on changing culture, sharing knowledge and intelligence. Of course, it's not our ultimate goal to repay the technical debt. It's more about improvements, continuous improvements. Meaning that in order for us to provide better service, better features, that's our goal. Line Android client evolution is something that we want you to pay attention to. Thank you very much.